Hi everyone. Our second model of division of fractions uses an area model and, like many of our other models, uses something a little bit extra. And this one brings in the idea of division as expressing division rather in terms of multiplication. And this is the definition of division. So division means if you say A divided by B, that means that A divided by B equals some number C if and only if B times C equals A. C is considered the missing factor. So if I say that 6 divided by 35, or excuse me, 6/35 rather, divided by 3/5 equals C, what that means is that C times 3/5 has to equal 35. So what number do I have to multiply by 3/5 to get 6/35? We can represent that, as we do with multiplication, with an area model. Start out with 2/7. Okay, so we say I'm going to take 6/35 divided by 2/7. Express that as a multiplication problem. So 6/35 divided by 2/7 is the problem. That equals some number C. And what is C? C is a number, so if I multiply C times 2/7, I'm going to get the product of 6/35. So the answer to the division problem is the same as the missing addend in this multiplication problem. So I start with 2/5, or 2/7, excuse me, and that's what I have here in green. I take the unit being the rectangle, and divide it into 7 regions. The green regions represent 2 of the 7 regions, or 2/7. Now the question is, and this is, I'll put a question mark there, what do I have to multiply my 2/7 by to get my end product, which is right here, 6 of the 35 regions that represent the whole. So the orange sections are 6/35 of the whole. So 2/7 times some missing addend, or missing factor rather, equals 6/35. So what do I need to do? Well, notice the 6/35, I've got the 7 sections horizontally. I would have to divide it into 5 sections vertically. So let's do that now as best we can. So I take my 5/7, excuse me, my fifths. So I take 1 unit, 2, 3, and 4. So if I section this off into fifths, and what I'd like to do, I'd like to get this section, the orange section. So what portion do I have? I would need to take, and let me do a different color. I would need to take 3 of these fifths. So 3 of the fifths would give me what's overlapped, remember, for multiplication, would give me that section right there. So what's the answer to this question? So if I multiply 2/7 times what it looks like is 3/5, I would get 6/35. So that says that 6/35 divided by 2/7 equals 3/5. Second example of that, 6/20 divided by 3/4. Again, what we'd like to do is start out by representing that problem as a multiplication problem. So that number equals C, and what is C? C times 3/4 equals 6/20. So I start out by, I'm looking for my C. This section is going to be my C. I take 3/4 of the whole, which is in orange. This is 3/4. 3/4 times what? C is equal to what? Is going to equal 6 out of 20 sections. So I divide this up into 20th, and I need 6 of those 20. So the green are 6 of the 20ths. How do I need to divide up C so that I get that 6/20ths? Well, it looks like, again, I need to divide this region into 5 spaces, or 5 sections. And to obtain the green region, I would need to take 2 of those 5 sections. So take 2 of the 5 sections, or it looks like 2/5 of the 3/4 will give me 6/20ths. So our C is equal to 2/5. And that says that for our division problem, since we figured out what the missing factor is, that also gives us the answer to our division problem, that 6/20ths divided by 3/4 equals 2/5. As we did with multiplication, these models are terrific for teaching students the concepts of division, the concepts of multiplication. But what you'd like to do is push the students beyond the models. The models are terrific for understanding, terrific for making sense of division and multiplication, but aren't necessarily the most efficient way to solve a problem. So where we'd like students to get, and what we will call is our standard algorithm, and that is, how do you divide A over B divided by C over D? This is what many teachers call keep, flip, change. KFC, keep, flip, change. The division A over B divided by C over D equals A over B times D over C. So if I invert, keep the first one, invert, or flip the second fraction, that gives me the division. A over B divided by C over D is the same as A over B times D over C, and that equals AD over BC. In the notes, I go through a justification of that, of why that works. This method, just using the symbols, is what we're going to call our standard algorithm for division.